The last thing I wanted to talk about coming up to the tail end of the session is essentially further capabilities. So there are a number of different additional features that are, they fall beyond the scope of this webinar. We only showed the absolute fundamentals, the sort of bread and butter applications of Rocky. But I mean, I've already brought many of these up, which includes a multi-physics coupling. So we can extend the range or the scope of our simulations to consider additional physics effects. Take, for example, a structural component of the response of the structure, whether that's a dynamic response or a quasi-steady state. We can consider this with a coupling with ANSYS Mechanical. In the same way, we can look at things like dust modeling or dust plume formation or suppression through CFD coupling. And actually, there are many different ways that we could address this type of problem, many different ways, and many different, with differing levels of complexity. So the first one would be a low-level sort of approach to generating or identifying a velocity field with a lattice-Boltzmann method coupling, which is embedded into Rocky. And the full fidelity version would be a full CFD coupling with DEM, where we would explicitly be modeling something like a formation of a dust cloud, as an example. We already mentioned multi-body solvers embedded into Rocky, and of course, if the isothermal assumption cannot be held for a given analysis, then there are, of course, thermal models in Rocky which can account for both conduction, convection, and radiative heat transfer. But one of the more interesting additional capabilities includes the integration of Rocky with OptiSlang, which can be used to perform sensitivity analyses or even optimization studies. So we can gain an understanding, as we can see in this graph at the bottom of the screen. We can gain an understanding, if we vary certain parameters, what will the system response be? So if we take, for example, varying the impact plate angle and the belt or the feed conveyor belt speed, how does the actual shear power or shear intensity change on the deflector plate itself? And we can create a response surface to describe this system. And so coming up, we'll be investigating some of these advanced capabilities in webinars to come.